Hi everyone and welcome to this project series on my YouTube channel. And we have already in previous video we have made one project which is iris flower detection classification project, and we have also made a website where we have connected backend, and so looking so beautiful our website, and also we had made a good model with a good accuracy in our previous video, and that was the end-to-end project. And then also I'm back with another project, as it is a little bit advanced from the previous video. So in this video we'll be talking about loan prediction detection system, or again say the system. Okay, so you will build the system on the basis of some features. It will predict whether the people will get the loan if yes or not. Okay, so we'll do that, and I hope that you will enjoy this. And in the front of your screen you have the website that we'll be building, and also integrating machine learning code from the backend. Okay, so we will code all them from scratch. The backend means a machine learning model because it is obviously a machine learning project. So code by yourself, and it's a template. I will tell you the thing that from where I have taken to get you a more better feel. Okay, to also make you more comfortable with. Okay, so you can see over here that we have a simple website, and over here that we have I have taken a template, so I have to replace it. So I'm going to do with yourself. And also at last, I don't know you all are able to see. Let me show you. Yeah, so you can see over here that my screen recorder is not fitting at the end, so I'm showing it now. So here you can put some values, and here you can click on predict, and then you can get your desired output. Okay, so we'll be doing this, and I hope that you will also enjoy. So till then, subscribe this YouTube channel if you haven't. Okay, but it's always your choice. I can't do anything. Okay, but I'm saying that I have a good kind of in my analytics that I have good kind of subscribers, and also I want you to watch this video till the end. Okay, and I'm working on my accent to make you more comfortable with my accent. Okay, to make the words simpler and a good way. Okay, so here is my Jupyter notebook that I'll be using on. So I've written a whole data science process life cycle that we're working on, and this is the font that I've used for you to get you the more home-like feeling, so that whenever you're using any kind of Jupyter notebook, you get a home-like feeling. That's it. And all the Jupyter notebooks, whenever I'm explaining many machine learning terms, you will get the same written in the same things. Okay. Okay, so let's start off. So the first thing that we will be talking about is loading and exploring the data, then working with the null values or missing values, then we're dropping the unnecessary columns, which is the 2 columns that we'll drop, and visualization or making a storyboard. I've just said that in visualization it is also a good data analysis project. We will work on data analysis a lot. We'll talk about visualization so that you can make a storyboard from that visualization. Then we'll code the categorical, the kind of a text to categorical variable. Then we'll start model development by using Gaussian Bayes. Loss function means precision matrix, and precision score, recall score, or maybe the accuracy score. And we'll use support vector classifier with the grids or CV for fine-tuning our hyperparameter, and then we will use XGBoost classifier with some hyperparameter tuning, and then decision tree using randomized search, and then random forest using randomized search. And randomized search, if you don't know about it, don't worry about it. Randomized search is a kind of a tool for getting you a best hyperparameter. Okay, so let's start off with that. Okay, so if you don't know about grid search, CV, randomized search, don't worry about it. It's very easy. I will talk about when I come to that. Okay. Okay, so let's start off. So the first mission is to load and explore the data. So let me load the data. So I will first of all obviously import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, then anything else, import cbarn as sns. Okay, so and backend I don't want anything. Let's use that matplotlib inline, great. Okay, so we have imported a library. I don't know why. Yeah, okay, so we have our libraries. Now it's time for loading our data. So I will name it as a train data. Okay, so pd.read CSV, and what you can do, you can simply write, I have in the dataset folder, yeah, in the dataset folder I have train this much. Okay, so now what you can do, you can take a look at the head of the data. You can take the head of the data. So let's take a look at the head of the data. So here it is. So here it is the head of the data, and we have a loan ID, gender, married, dependents, and let me explain you what is all the feature says and what's it all. Okay, so loan ID is the unique ID for each loan. The gender is obviously the gender of the person. The married, if the person is married, no, if yes. Okay, dependents, it means whether the person is dependent on another people for source of income, 0 or 1 in the categorical values. Education, graduated or not graduated. Self-employed means whether he is self-employed or not. Applicant income, what is the income of the applicant, means whoever wants the loan. And co-applicant income, whether his wife or anything. Loan amount, what is the amount of the loan he want to take a look at. Loan amount term, what is the term of the loan amount. Then credit history. Then we have a property area, in which property area, urban, rural, and one more here. And then the final target variable, which is the loan status, whether the loan will be approved or not. Okay, so this is the basic columns over here. And okay, so let's just start off. So first of all, let's take a look at the shape of the data, train data dot shape. So let me see if I can make a good formatting, but I don't want to maybe waste your time so much. Print train, and now we can just take a look at the shape of the data for now. Okay, so there are 614 rows and 13 columns over here. Now what we can take a look at that, we can take a look at that train data dot info, train data dot, let's say, describe for numerical values. So to describe it, and for numerical values, and the count of the whole 614, and a minimum of 6403 means the kind of a minimum mean standard deviation, minimum 25% of the whole data, although in the particular feature 50% of the whole data, and 75% at the max. Okay, so I hope that you are familiar, that you got intuition behind describe. Now let's take a look at the info, and here it is. So here it was the D type, and it's a null or non-null. Okay, so this is the null and non-null, and this is total of my memory usage, etc. Okay, so now it's time that we have taken a look at explore the data too much. Now it's time for working with missing values. Okay. Okay, so we'll define one function here, and it will take a df, and it will give the percentage of a null values over there. Okay, so first of all, we will have to simply give the let me show you the number of null values. Number of null values. Oops, I don't want to remove all. So my simple way is to take a look at dot is null dot sum. Okay, so you can do this and you are good to go. Okay, so now or you can do simply using that, but having a function works best. You can simply write the mainly the and per percentage of null values remove from there, and you can type train data over there. So it will show you, and I have to return it. I have to return it. Return. Oops, it should be containing an A, so sorry. Let's return it. Return A. Okay, so you can see over here that in loan ID, in gender, and in gender we have 30 null values, in married we have 3 null values, in dependents we have 15 null values, and self-employed we have 32 null values, and a lot more. Okay, so we'll deal first of all with categorical, and then we'll deal with numerical. Okay, so let's start off dealing with null values. I will write categorical. Okay, so we can do this. Okay, so here we can see over here that we have a categorical values. we have a categorical values. We have a gender, which is a categorical values. Married, which is obviously the categorical values. Dependents we will remove this because it has a kind of a 3+ kind of thing that is not okay with some algorithm. So remove this. And education, it is also categorical. Self-employed, also a categorical. And also here it is, we have to encode it. Property area, which is also categorical. And over here that we have loan status, which is also a categorical. Okay, so we have to convert that into kind of take a look at the null values over there. Okay, so in which column? Gender, married, dependents. But first of all let's remove them without further ado. So first of all, what would I have to remove? Train data drop. I have to drop 2 columns. First of all, the loan ID. Oops, I want to drop the loan ID, and then I want to drop the dependents. Okay, I want to drop the dependents. Now I will write access equals to 1 and in place equals to true. Now it looks good. Okay, so for verification check, we can take a look at it. No, oops, I don't want it to be converted. Code train data. Now you can see over here that it has removed all the things. Okay, now let's start off. So we have in gender, and let me make one column. Calls, it will consist of all the columns which has no values. First of all, gender. Okay, so let me copy it. So let me come over here. Let me do for all instances. Gender, and then we have married. Then we have removed dependents, but we have education. In education, I think we don't have married. Okay, in self-employed, let me do here also. Train data, that is no, that sum. So it's just will be easy. After self-employed, applicant income, no. Credit history, loan amount, no. So there are 3 categorical values which has a no values. So we will have to deal with that. For I in train data, for calls, let me say calls, and I will write it down like this. I.fill na train data, let me say I again, I.mode.ilog 0 in place equals to true. Oops, it's a fill str object doesn't have any kind of a fill na attribute. So what I can do, I can write over here like this. I hope so that it will work. Either I can. Okay, great. So if I run this, so now we have in categorical values, we don't have any kind of null values over here, and we only have the numerical value, which is loan amount and loan amount, etc. Okay, so let's start dealing with the numerical values. Dealing with numerical values which named as numerical. Okay, missing data. I will write missing data. Okay, so the calls that have a missing data, which is obviously train data. The first one is loan amount, which has around 22, and then we have a total of loan amount term, and then we have credit history. Okay, so then we have our favorite credit history. So let me make it n calls. Okay, so for I in n calls, I can write train data I dot fill na train data I dot fill, sorry, mean axis1, mean dot axis1, I will say in place equals to true. In place equals to true. Oops, it should be 0. I'm talking about rows, so now it looks good. Now if I take a look at it again, let me show it again to you. Oops. Yeah. So now it's all 0. Now we're good to go further. Now what I'm planning is to start visualizing the things. So now we have drop and drop, disregard, etc. And now we can start visualization or making a storyboard. Okay. So I hope that you all are able to see this. Yeah. Okay. So from here I will start visual. Yeah. Okay. So here we have a bar chart. Means I have made one column with a bar chart, which can take a column which is input, and then it will show the distribution of the column with respect to the following target variable. Okay, so here what I've done, approved means if the loan is just approved, then count the values with respect to the column, and this disapproved with respect to column, and then pd.data frame, then we are converting it and then plotting it out. Okay, so first of all, let's start off with a gender. Okay, let's start off with a gender. Now you can see over here the male is approved too much into the approved with respect to the approved target, and in this disapproved, male has been also the disapproved lot rather than female. So if I take a look at a bar chart of let's say married, yeah, here it is. So the approved one has married, and disapproved one, the male means kind of has married also. Okay, now the next what we can use the bar chart. Next column, let's say the education, oops, it should be education. I can see over here the one who is graduate have a high chance of approval. And the next what you can do, he's a self-employed or not, so we can use that. So let me say bar chart. Okay, let me see. Yeah, so the one who is not a self-employed has a high chance of approval. Okay, so I think that this is storyboard, you can write this out like this. So the one who is a male has a high chance of approval rather than female, and the one who is a male also has a high chance of disapproval rather than female. Okay, and the one who is married has a high chance of approval, and one who is not has a less chance of. And then one who is graduated has a high chance of approval rather than not graduated. And one who is self-employed has a high chance of approval rather than not self-employed. Okay, so you can make this type of storyboard for understanding your data in a more specific way. Okay, so now we have completed our visualization. Now it's time for getting into the kind of encoding the categorical variables, or ordinal encoder. Now it's time for ORD encoder dot fit, good to go. Okay, now we can take a look at a train data dot head, and I hope that all the one who is here is now categorical. But there is some kind of a problem over here. I think that we don't want this kind of thing, means here all this to be maybe the train data dot, we don't want this all to be, so I will write convert it to the as type to be integer. Okay, yeah, okay, so let me convert it also. I can write here. Okay, so now I hope that it should run fine. Yeah, now it looks good. Okay, so we have done with it encoding the variables. Okay, so now we can start off with the model development. So let's start off with the model development. I hope that you all are able to see this. Okay, from sklearn dot model selection import train testlet, and then I will from let's start off with it, and let's divide our data. Okay, so train data dot drop I can say, oops, yeah, loan status. Here I have loan status and access number one. Oops, access number one, and it's good to go. Y equals to train data, which is obviously the loan status. Okay, now it looks good. I can divide x train, y train, x test, and y test. Oops, it should be x test and y train. X test and y train and y test. So we can call our train test split function, and then we can call xy test size should be 0.3, and random state should be around, let's say 2. Okay, maybe 2. Okay, great. So print x train dot shape. Yeah, and we can do for y train also. We can do for y train dot shape. So let me copy it for saving the time. Okay, x test and y test. Okay, now it looks good. So we have a let's take as a 2, not too much. Okay, so we have a 491 for training. Obviously it is too low, but it works fine for us. Okay, so now it's time for, we have divided data. Now it's time for using the Gaussian Naive and using the scikit-learn API. From sklearn, I will from sklearn.naive, I will import mainly the, let's say, Gaussian Naive. I've tried multinomial Naive, but it's given a worse out of worse among all of the following. Because in the Gaussian Naive is for categorical, I've seen. Either you can try it Bernoulli. Let's see what is, but for now I'll go with Gaussian Naive because I listened over time. GFC equals to Gaussian Naive. GFC dot fit x train and y train, and then prediction 1 equals to GFC dot predict, I will say, x test. Okay, great. So we have x test, which is all of these, and here in prediction 1 it says whether the particular example is will be approved or not using that train model. Okay, now how do we check the accuracy of this model? For checking the accuracy, I will define a loss, and it will take y true. It will take y true means the actual grand truth and the predicted value. Okay, and for evaluation matrix, I will use precision accuracy, recall score, and the accuracy score. Okay, from sklearn.matrix import accuracy score. Sorry. Precision score. I have a chance for whatever I say should be written up first. So recall score and accuracy score. Now it looks good. Okay. So now what I can do? I can take out precision. I can write precision score. Okay, so I can write this as a let's say y true, then I can say y, and the tip number 1 is you can use tab for the autocomplete. Okay, a good tip. Recall score, it should be y true and y prediction, and obviously this accuracy score. Yes, accuracy score. Obviously, we're going to write y true, y true, and y bred. Great. Now, what you can do is print pre, print rack, print ack. Done. Okay. So now I can take a look at a loss with the giving the y-test as a ground truth and prediction 1, which we have predicted. It says that the precision of this particular Gaussian Nye base is 77, which is closer to 1. Recall, is closer to 1, and the total accuracy is 78%. Okay? Good. Okay, good. Next term, support of the machine. Okay? So I'll be using a define the loss function. Now it's time for SVC with the grid search CV. Okay, so let's start off. From scale learn dot let's say svm import SVC, and I will write SVC equals to SVC. I will write all those hyperparameters just in a second. But before that, I will from scale learn dot, let's say, model selection import grid search CV. Okay, now I will define a params grid, and in that params grid I will define some of the parameters. So I will define it in just a second. Okay, so the first thing that we want is obviously C, then we want the kernel to be used, obviously the RBF kernel for this, and then we will we'll also want maybe the gamma is not required for this. Use the gamma between the param grid, provide the param grid. You can use that for the following. Okay, so it is telling to use the best parameter as all of these. Okay, so I can use this kind of thing, grid dot best params. Okay, so here it is the best parameters of the lists. Okay, so you can use this. So obviously you can use this. So let me use that. I want it to be not like this. C should be RBF kernel. Okay, now it looks good. Okay, so I can copy this, cut it down, bring it back here, and svc dot fit, and I can fit over x train and obviously the y train, and prediction number 2 equals to svc dot predict. We'll see svc dot predict. I will see predict, and it obviously takes x test. Okay, so I can write accuracy score, and in that accuracy score I will write a y test and obviously the prediction 2. Okay, it's good. Oops, we have a loss now. Okay, so we have means kind of a not good support vector machine is not doing well. Okay, so now I have fine-tuned the XGBoost already but it from a blog. So I will link a blog in the description box below to get you a better feel of how XGBoost works. You can feel free to skip the step of XGBoost. However, we'll not be using XGBoost for this, but for maybe understanding, you can continue with this. How do we implement XGBoost? Okay, so we'll pause this video and write the code, and then we'll come back because this is just hyperparameter settings. And then I will. So the number of estimators, means entries 1000, max stepped, 3 minimum child, 1 gamma, 0 subsample 0.8, then binary tree 0.8, objective or a large iteration binary objective and thread, then seed, then we are fitting it all up, and then this is our prediction tree, equals to, by the way, I'm not showing this to you that how I fine-tuned it. I will show you how you can fine-tune the decision tree or random forest using randomized search. But I've showed you grid search. You can try it out by yourself about XGBoost. Okay? So let me show you. Yeah, XGB dot predict. What time it is? Let me see. Okay, predict X test, and I can calculate the loss obviously, and it takes Y test, and obviously the prediction tree. It's taking some time. A bunch of warnings. Okay, so here it is. So we have a total of 73% accuracy with precision and recall of these two of these things. Okay, works best. Work good. How much accuracy? 73%. Okay, great. Now we're gonna use decision tree using randomized search. So what do I do? What I will do? I will just write a code. So for preserving the time. Okay, so let's start off with, first of all, I will define a randomized search. That tree equals to 2. Okay, now we can instantiate the random forest, means randomized search. Okay, so I've written that, and here we have a best score, which is the best score, and we have for the best estimator, and then it's good to go. Okay, so I will define one parameters grid as a long grid. So I will define in fast way. I've taken from the internet, so I will just copy and paste over here. See, okay, the search. Oops. Okay, so it is running. Oops, what is ran CLF is not defined. What I said. So we have a training score of 0.819 and testing score of 0.777 with all these features. So we'll just copy and paste this. ds equals to decision trees and ds dot fit and x train obviously and y train, and obviously the prediction number 4 equals to ds dot predict X test and prediction 5. Oops. Loss Y test, and it will say Y predict. Predict 4. Okay, so we have this, and it's good to go with have this kind of thing. And to whom which I suggest to go with is. Let me see to whom which I can go with, as is seeing that kind of a Gaussian is doing well. But what it suggests is one more forest has a model algorithm is left, which is random forest. But what did I recommend you to do it by yourself? The solution for making this random forest is in the description not much below, and my GitHub repository already done. Okay, so homework, try it out by self. Okay, great. So now what I will do, I will save one of the model. Let's save the decision tree classifier. Let's save that because I've worked a lot on decision trees. So I will save obviously the one you choose, the better you have. Okay. So sorry, I've told the wrong quote. The one algorithm you choose, the better accuracy that have. Okay. So model joblib.dum, and the ds, obviously ds, and the name will be model.pkl. Okay. Joblib dot, let's say, predict. Yeah, no. Let me check if it's working or not. Model dot predict. Sorry, joblib dot load, because I'm recording at 40 minutes. My mind is diverting. So load. I will load model dot pkl. Oops. And then model dot predict. I will predict it out. And here it is. So X test. Yes. Okay. So if I show it to you, actually, here it is. So you have a model which is like this, and I hope that it doesn't have been saved. Why, I don't know. I think here it has been saved. Okay, so great, we have done that, and our model.pkl is being there. Okay, so let me copy that model.pkl from there and make it to the loan prediction over here. Okay, so we have model.pkl, and now we are good to go. We have predicted that it is giving us an output over here, and we have saved the decision tree as a thing. Okay, now it's time for starting building our website. For a website, here you can see that I have let me show you the structure of the folder. Videos, I don't know where it is, projects, reviews, then we have a loan prediction project here. So I have my IPNIP, it's all Jupyter Notebook, model.pkl that has been output, app.py which is Flask visual code, and templates I have empty file, all those, index, layout, predict, and then I have a static. In the static I don't have any kind of images, I will put that just in a second. In data set, I have to the set I pin up checkpoints. Okay, so let me put the images over there. Okay, so you can put this over here, and this is just an example design. Okay, so let's start off with. So first of all, I will design the index.html. I am in index.html, and you can review all the code in the description down box below in my GitHub repository. So let's start off. So first thing first, what you have to do, you have to go on to the Tailwind CSS. Okay, head over to that, go to Tailwind CSS, head to get it started, head to installation, and go down. Okay, go down and copy this. Okay, and under meta, let me take out a boilerplate code, under the meta tag, put this tag. Okay, now it will work fine. Now what you have to do, you have to go to tailblocks.cc. Yeah, my favorite for making any kind of thing. Okay, so first thing first, what we have to do, we have to add the header. So let me search where is the header. Yeah, here it is. So I will use this header, and I can make it as a dark, and I can click on view code. Okay, so you can simply here you can make the dark, and yeah, at the corner. Okay, let's start off here and let's paste it out. Now let's save it. Now let's open with live server. The live server is an extension. You can find it in the description, kind of not in the description, it's an extension. So you can see that we have a good thing. And now it's time for the content that we have to put. So the content that we'll be going to put, let me see what's the structure would be. Yeah, the content. So let me see what content works best for me. For me, let's say this works. No. Not this also. Not this. You can use any of these. Okay, so let's use this, and let's try to copy all these things for a good thing. Okay, so I'm just going to copy it, and I'm just going to paste it under the header tag that we have. Okay, save it. You can see over here that we have a good website that is just like this. Okay, but one thing has left. We want this kind of thing. So let's see. Let's search for that feature, footer, gallery, header, hero. Yeah, this one. Okay, so we can use this. I think this one. So I can copy it down. Let me copy it. Before the header, I will push that. Here is the header. Yeah, here it is. Okay, so I'll save this. Now it looks good, and we can remove the dummy kind of thing from there for giving a good look. Yeah, here it is. So I can simply make it static and that untitled design, which you can find in the description down box below. Now it looks good. You can replace the button and all those things by your own self. Okay, now the next thing you have to do is for simple, maybe the contact page. Okay, let me write form. Nothing form here is there, so let me find a contact. Here it is. Okay, so I'll be using this one, but for an instance, let me copy it out. Okay, let me copy it out. Let me copy it out and paste it, and let me paste it at the end. Okay, and now one thing, because we don't want like that all those things, I will be putting my custom form over here. Okay, so let me do that and then I will come back, and all the code is again in the description box below. Okay, so I have made that. I don't know you all are able to see it or not, because my screen recorder, yeah, here it is. So I have done like this, as if you're a web developer, you can do better than me. But what I've done is simple. I have a form. I have started a form with action predict with this URL, and I have done the same thing. I have used the same font, etc. I've just changed the labels. I've just changed the labels and the type to text, and make sure that your ID, labels, and names should match, and all those and all 10 features. Okay, do it, and your button should be like this. Okay, now you're good. Now your website looks good now. Okay, now what you can do, you can simply go to app.py. You can simply go to from Flask, import Flask. I can import render template. I can import request because it's needed. And what I can do, I can let's say Flask name, and then I will app.route. It's just simple here. Define home, and just rendering the template, return render template from index.html. Okay, and if name is equals to main, app.run debug equals to true. Okay, good. Let me run this out. So my server is started. Let me follow the link. Great. Okay, so we have this, and I hope that you can use any color or font that you want. Okay, now we can define a predict. So as usual, and in our previous project we have done that. We are going to do the same. So let me copy that from there, but I have made my own. So let me copy the whole thing from here. So here it is. Okay, so it's out of running time, so that's why I'm doing copy and pasting over here. Yeah, okay, now it looks good, and I'm going to make a pre-processing step just in a second. So it is just doing the same. It is request.method is getting the from their labels, all the 10 forms. Okay, and then let's make one utils.py. Let's make one utils.py, and into that utils.py I will do this, and again the same thing is there. We have taking all those features and doing the same, and I can import the utils over here, import the utils, and from utils I can import what is pre-processed data. Okay, now I think it looks good, and now we are done with that, but one thing is left. We want to make the layout that we have done in our previous. So let's copy again the layout and predict from our previous sections. So let me copy the layout and all the code in description box below. You don't need to learn all those things. This is just for showing your website on the. You can just change the template and it's your website. Okay, you can just change something, the font, whatever the style, and then you're going to go just take inspiration from what I'm doing just now. Okay. So I'm using the placeholders here, and it's good to go. Now I have good thing over here. Now let me save it all. Let me save it. Save it. Save it. Let me wait for it for running it out. Now here it is. Okay. Now let me provide some values over here. Let me provide some values. 0, 0, 0, 549, co-applicant answer 0, loan amount, let's say 146, 360, 1.0 for predict. Okay. So it will give me the whether the particular is the loan approval, and I have checked that is a yes. Okay, so it is saying you can customize the predict.html in a more beautiful way if you want. I've lived upon you for doing that. Okay, now I hope that you got better intuition about all those things, and we have made the website, which looks very good in my perspective that I made, and using Tailwind CSS, tailblocks.cc. Don't forget to check out that website. Okay, and also don't forget to subscribe to this YouTube channel. So it's a lot of time to simply what again say make content. Okay, and make sure the GANs course is coming up, machine learning course is coming up, DSA course is coming up, it's running also. I'm pushing a lot of videos, but I'm just after this I'll be pushing up kind of a DSA Master Course videos, and about the notes of the DSA Master Course, you will get the notes on the tomorrow. Okay, not the how do you implement tomorrow, and our DSA playlist, go there. If it is there, it's okay, but if it's not there, I will be covering up. Okay, then the whole notes, stacks, queues, LinkedIn, sorry, not is the linked list. Okay, so we'll talk about that. Okay, so thumbs up and high five, and then I will meeting up the next video. Till then, bye bye, take care, and do not go outside, sit in the home, watch my video. Till then, bye bye.